In this video, we are going to study modified Euler's theorem, which is given as x dou u by dou x plus y dou u by dou y equals n times fu upon f dash u, where n is degree of the homogeneous function. In my earlier videos on Euler's theorem, we have seen that Euler's theorem can only be applied to homogeneous functions. So before we apply Euler's theorem, we first have to confirm that the given function is homogeneous. Sometimes functions like u equals sine inverse x comma y, where x and y are two independent variables, may not be directly homogeneous functions, but if we write them sine u equals x comma y, they become homogeneous functions. Similarly, functions like u equals log x comma y to the base e, a function with two independent variables, may not be directly homogeneous function, but if we write them e raised to u equals x comma y, they become homogeneous functions. We can name functions like sine u, e raised to u, etc. as fu, whose derivatives f dash u will be cos u, or f dash u equals e raised to u, and then by knowing the degree n of this homogeneous function, we can find value of x dou u by dou x plus y dou u by dou y by using this modified Euler's theorem. Let us see how. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. For the sake of understanding, let us verify modified Euler's theorem for a function u given as sine inverse square root of x square plus y square. By putting x equals xt and y equals yt, function u will become sine inverse x square t square plus y square t square, which is sine inverse t raised to 1 square root of x square plus y square. Here u is not in the form t raised to n times sine inverse square root of x square plus y square. Obviously, u is not a homogeneous function, so we cannot apply Euler's theorem to u, but we can write function u as sine u equals square root of x square plus y square. Let us name sine u as fu, and in this, if we put x equals xt and y equals yt, this will become square root of x square t square plus y square t square, which is t raised to 1 square root of x square plus y square. So here fu, which is now sine u, can be written as t to the power 1 square root of x square plus y square. Hence fu is a homogeneous function, so f dash u will be cos u, and the degree of this homogeneous function is 1, so we have n equals 1. Now by using this modified Euler's theorem, we can find value of x dou u by dou x plus y dou u by dou y equals n, which is 1 times fu, which is sine u, upon f dash u, which is cos u. So the required value will become tan u. Now this is according to modified Euler's theorem. Now for verification, we will find x dou u by dou x, which will be x times du by dx into dou by dou x of square root x square plus y square, which is x times du by dx will be 1 upon under root 1 minus square of square root x square plus y square will be x square plus y square into partial derivative of square root of x square plus y square with respect to x 1 upon 2 square root x square plus y square into derivative of x square 2x. This 2 will get cancelled and x dou u by dou x will be x square upon 1 minus x square plus y square into square root of x square plus y square. On similar lines, y dou u by dou y will be y square upon square root 1 minus x square plus y square into square root of x square plus y square. After adding x dou u by dou x and y dou u by dou y, we will get x square plus y square upon under root 1 minus x square plus y square into square root of x square plus y square. The right hand side of expression 1 will become x square plus y square upon square root x square plus y square will give us square root of x square plus y square upon this square root 1 minus x square plus y square. We name this 2. Now from this sin u is equal to square root of x square plus y square. Sin square u will be x square plus y square. Cos square u will be 1 minus x square plus y square and cos u square root of 1 minus x square plus y square. Therefore, expression 2 will become x dou u by dou x plus y dou u by dou y equals, for this square root of x square plus y square, from here we write sin u, and from this denominator square root of 1 minus x square plus y square, from this we write cos u, which is tan u, same as this tan u. This is how we verify modified Euler's theorem. A function u tan inverse x plus y upon root x plus root y. To check whether u is a homogeneous function or not, we will substitute x equals xt and y equals yt, so that u becomes tan inverse xt plus yt upon root xt plus root yt. That will be tan inverse of t raised to half x plus y upon root x plus root y, which is not in the form t raised to half tan inverse of x plus y upon root x plus root y. Therefore, u is not a homogeneous function. Now, we can write u equals tan inverse x plus y upon root x plus root y as tan u equals x plus y upon root x plus root y, which after putting x equals xt and y equals yt becomes xt plus yt upon root xt plus root yt, which becomes t raised to half into x plus y upon root x plus root y. So here we can write tan u as t raised to half times tan u. This shows that tan u is a homogeneous function of degree half, and if we write tan u as fu, then f dash u will be sec square u. Hence, for fu equals tan u, we can write x dou u by dou x plus y dou u by dou y equals n, which is degree half times fu, that is tan u, upon f dash u, which is sec square u. So, modified Euler's theorem is for functions like which are not homogeneous as they are given, but when they are written in this form, they become homogeneous functions of some degree, in this case half, and then we can use modified Euler's theorem to find the value of x dou u by dou x plus y dou u by dou y. Consider u equals log x square plus y square upon x minus y, for which we have to find x dou u by dou x plus y dou u by dou y. In this function, if we put x equals xt and y equals yt, u will become log x square t square plus y square t square upon xt minus yt, which will be log t times x square plus y square upon x minus y. So u is not in the form t raised to n log x square plus y square upon x minus y. Hence, u is not a homogeneous function. But if we write this function as e raised to u equals x square plus y square upon x minus y, the base of this log is e, and this is according to conversion of logarithmic form into exponential form. Now here, if we name e raised to u as u and put x equals xt and y equals yt, then e raised to u becomes x square t square plus y square t square upon xt minus yt, which will become t raised to 1 times x square plus y square upon x minus y. Since here e raised to u is t raised to 1 times e raised to u is a homogeneous function fu, and f dash u will become e raised to u. Therefore, x dou u by dou x plus y dou u by dou y will become n, which is 1, times fu, which is e raised to u, upon f dash u, which is also e raised to u, and this value will become 1. So we can find x dou u by dou x plus y dou u by dou y of a function u log x square plus y square upon x minus y to the base e, which is originally not homogeneous but becomes homogeneous when we write it in this form, and it becomes homogeneous and we are able to find the required value. If u is 1/3 log x cube plus y cube upon x square plus y square, we have to find x dou u by dou x plus y dou u by dou y. We will put x equals xt and y equals yt. So u becomes 1/3 log x cube t cube plus y cube t cube upon x square t square plus y square t square. That will be 1/3 log t raised to 1 times x cube plus y cube upon x square plus y square. So u is not in the form t raised to n 1/3 log x cube plus y cube upon x square plus y square. Therefore, u is not a homogeneous function, but we can write u, which is 1/3 log x cube plus y cube upon x square plus y square to the base e as 3u equals log x cube plus y cube upon x square plus y square to the base e, which finally becomes e raised to 3u equals x cube plus y cube upon x square plus y square, which after putting x equals xt and y equals yt as x cube t cube plus y cube t cube upon x square t square plus y square t square. So what we get here is e raised to 3u equals t raised to 1 times x cube plus y cube upon x square plus y square, which is nothing but t raised to 1 e raised to 3u. Since e raised to 3u is t raised to 1 times e raised to 3u, e raised to 3u is a homogeneous function of degree n equals this one. Let fu equals e raised to 3u so that f dash u will be 3 times e raised to 3u. So according to this modified Euler's theorem, we have x dou u by dou x plus y dou u by dou y equals this n times, that is 1, fu, which is e raised to 3u upon f dash u, which is 3 times e raised to 3u. After cancelling e raised to 3u, we get the required value to be 1 upon 3. Viewers, if you like this video, please click the like button. Share this video with your friends and classmates. Subscribe to this channel. Post your constructive comments to make the videos better. See you in the next video. Until then, keep watching Number Collage. Thank you.